The code is all open source and I love contributions. I'll talk about it at the end. So you can build your own using the code that I have. So personal story with me, how I got interested in this topic was during COVID, I started trading and I made millions of dollars. And then I lost most of it. And the reason why I lost was I did an introspection and I realized that the problem with humans is that there is a lot of greed and emotions and act emotionally. And as I learned a rather painful way, market is not a place where you have emotions. Market is a place where you have to be cold-blooded, rational, right? So that's how I got interested in automated trading, because the best part of computer programs are they're dumb. Okay? You tell them what they do, they just do it. They have no greed, they have no impatience, they have no emotions. You program your strategy, it works. So I'll talk more about it, but let's start with the objectives of this talk. Okay? So I'll explain what a trading bot is, why do we need it. I'll go about some base architecture patterns for trading bot. Okay? I'll talk about common trading strategies and some of the implementations. Now, people study quant for 2 years, so I can't teach you a trading strategy or pretty much everything about it in like less than an hour. So what I have is I have links that talks about different strategy, and I'll just pick one or two and just kind of implement. So that kind of gives you a feel of what I'm talking about, but obviously it's just an introductory more than anything else. You won't really learn trading so much as I would have liked to have, but never mind. Okay, a disclaimer, trading is risky, use your own judgment. Also, all examples are for illustration. Please don't use it with your actual money, you're going to lose. Right? I'm here more to teach you that as opposed to make money. The thing is that we'll talk about it. So start with what is a trading bot, okay? A trading bot basically is, obviously it's a bot that you program your strategy ahead of time, and it actually executes it. And in a very simple term, it's basically an execution thread. We'll talk about what an execution thread is a little later, but think of it as a loop, okay? So you source data from some data source, and I'll show you the sources. You analyze based on your strategy. You make a decision, do I want to trade or not? You don't actually trade on every data. In fact, you rarely do. And if you do come up with, yes, I want to trade, this is my order, you place an order, okay, the order gets executed. Typically, it's a bracket order, so you have a profit limit, you have a loss limit, We'll talk about what a bracket order is. And then you go back and you run this loop, right? So that's your execution thread. And what you have is you also have some kind of exit strategy. So a disciplined way of trading is that you start with an objective. Say, today my objective is I'm going to invest $10,000 in the market, and I am going to have a 20% return for the day. So I'm going to, at the end of the day, at the end of trading day, if you're doing like stock trading, because it's a day, crypto obviously runs 24/7. At the end of the day, I want to make a 20% profit, or I'm only willing to take $2,000 loss. So you have some exit conditions that you define, right? So during your analysis, if you find that you have reached one of those exit conditions, you stop. So that's essentially what a bot would do. The real question is, why do I need a bot? I could do everything myself. Well, as I said, the advantage is that bots act rationally, right? They don't really have emotions. Your two biggest enemies in trading is greed and impatience. So I'll tell you what happened with me. So at night, usually at evening, I go for a walk. And when I go for a walk, new brilliant ideas come to my mind. Then at night, I write down my strategy and I program my strategy. The next day morning, I'm based out of Pacific time, so I get up at like 5:30. The market opens at 6:30, so I'm up. I check my strategy, everything looks good. Most of the time I have brilliant strategies, but I screw up in the execution. Now what happens after that? So let's say I decide that I'm going to enter a trade on Tesla stock option, okay? An option is right now valued at $100, and I believe it's going to go to 120. Fantastic. And I'm going to make an exit. Everything looks good. I start. The market improves as I expected. It's now 110, 115. I said, well, this is going really well. Why did I set for 120? Let me do 125. That's even better. Sounds good. Now I cross 120, and the market value right now is 122, 123, and I'm like, I'm obviously going to make more profit in this. Let's do 130. Go 130. Even hit 130. But if I keep doing that, essentially at one point of time, the stock would take a pullback. And I never hit my targets. And then I take a pullback, and I ended up with a good loss. What I should have ended was at least a 20% profit. And why? Because I got greedy. And this is the problem that most of us humans have. We get impatient, we get greed, and this is something that the computer program eliminates. You tell it, this is what my exit strategy is, you just monitor it, you step back. Let it do its job. And very many cases, what happens is, at least with me, that my strategies are really good, my executions are bad, my bot would improve the execution, and that's great. Very many times what happens is that I can take more profit than I initially thought, because I'm, as contrary as it sounds, I'm actually very conservative. I don't take a lot of risk in life. If I know that I'm going to hit 20% profit, then only I make my money. And very many times the profit could go 25, 30%, and I miss that extra profit, but that's okay. As a trader, you don't have to take every call, okay? You don't have to take every trade. You don't have to win all the time. You just have to win most of the time. Even the best of the best investors are never 100% right. If you could get a ratio of 75% to 80% success, that's actually really good. Very many times I've left money on tables and I don't regret it. So that's the reason why I like bots, because I just program my strategy and I make a rule for myself: do not change it. Stick with it. Okay. One of the things about bots are that they can do a very fast execution, right? More than a human. It is believed, I don't have any numbers, but it is believed that 70% of trading that you see is driven by machine. About, could be a little more, little less. And even for retails, and what a very common strategy that people use is they use sentiment analysis using NLP. So they have a feed where you basically get some piece of news. Using some NLP, you kind of get, is this a good news or is it bad news? And if it's a good news, you quickly enter a trade. And if it's a bad news, you can do the opposite, you can short it, okay? And after that, you enter trade, hopefully you were right in your sentiment analysis, the stock would improve, and then you sell it, and you make like 0.5%, 1% profit, and you keep doing that, you'll end up with like 15, 20% profit. The thing is that you have to make a decision faster than a human can read or write, right? And that is where a bot would shine, right? It's not going to be 100% accurate, but as long as you can do like 75% accuracy or 80% accuracy, but really fast, you would basically outdo a human, right? Unfortunately, we humans, as much as we would like, we can't really compete with machines, to be honest, if the machine is smart enough. The second thing about bots are that they can analyze a lot of data from a lot of data sources. I, as a human, when I do manual trading, what I do is I focus myself on 2 or 3 stocks, because that's all my limited capacity is. And I don't care about what happens after that, okay? But with a bot, what I can do is I could just scan like 50, 60 symbols at the same time and process. So the advantage that I get is that I can analyze a lot of data. And the best part of automated trading is that most of the brokers would give you like historic data. So I have an ability to backtest my code. So I can run my strategy, across like, okay, what happens in the last 5, 10 years? And if my strategy is right most of the time, I have a lot more confidence. As a manual trader, you go by your intuition, and intuition is great, but it's even better if it's backed by data, right? So you develop your strategies by intuition, but you test it using data. So now this is a functional programming conference. So let's talk a little bit about functional programming. Why do we want to use functional programming as a part? And I have some interesting stories there. In some sense, if I was to reduce a bot in one line of code, and this is F#, but I should mention this, that while I'm talking about F#, much of what I'm talking about is applicable to any functional programming. So my code is going to be in F#, but if you're a Scala or any other developer, you could pretty much translate and use all the principles that I'm talking about. But in very simple terms, in one line, this is what your bot is. You have a data, you have a strategy, which is a function, a pure function, because you don't have side effects, right? You're only relying on this data, and then you generate an order. And that order is an option because you don't generate order on every piece of data. If you think you have something there, you place an order. If not, let it go. I've used options, but in real life, I actually don't use option, and I'll explain why. So the advantage of functional programming is that functional programming, especially when you use pure programming, the code tends to be a lot more correct. So you can eliminate bugs. Bugs are very costly in your bot. One bug here and there, you're off by $1 million. Bots are executing very fast. So you have one bug, even before you blink an eye, you lost $1 million. Good luck with that. So functional programming basically gives me confidence that I can write code which is bug-free, or mostly bug-free, not always. There are some general benefits of functional programming. We have productivity, we have speed. Everybody knows that. But most important, it's very easy to code new trading algorithms and tweak an existing ones. So towards the end of the talk, I'll actually show some code for technical indicators. And most of that code I've achieved using 5 or 6 lines of F# max. And I'll show you a Java implementation, which is 60 lines of code. But we'll go towards the end. But here are some of the things that I actually just randomly Googled. And so these are examples of some trading glitch that costed 400 million plus to this Knights Capital Group. You hear all the time security breaches and so on. So correct code is very, very important here. Okay. And let's talk about a reference architecture, and my animations are a little bit off here, but I modified it in the morning. I screwed up, but never mind. So basically, when you think about this architecture, there are essentially 2 threads. Now, I showed about the execution thread, right? The loop of taking the data and using a strategy to analyze and execute. So that's the execution thread. But at the same time, how do you get a data? Okay, the way you get a data is you subscribe to market, and using typically WebSockets are the one. There are 2 ways of getting the data. There is a pull data and there's a push mode. In pull mode, you make a REST call to some broker, you get some data, put it in your data store. That's usually not a good way of doing it. Most of the brokers would give you a market feed option where you have a WebSocket connection open that you basically open, and then automatically the data is pushed. And it's pushed to your data store, which is basically a thread saved data store, because you have 2 data, right? The execution thread would pull and the reader thread would basically put the data. And then you have a circular array, and I'll explain a short while why I use a circular array. In the example I'm doing is on a crypto. So you have a circular array, which, for example, Ethereum and Bitcoin, and essentially your data store is a map of your symbol and an array. Now, why do I use a circular array? In general, and this is particularly a problematic thing in garbage collected languages, is you don't want garbage collector to run in the middle of your trade, right? Because it's going to pause your threads. So how do you prevent garbage collector from running? You cannot prevent garbage collector from running. But what you can do is you can make it run really infrequent by not generating garbage. So the philosophy is that I know exactly how much data I'm going to get. For example, let's say I'm getting a feed of let's say I'm subscribing to Apple, okay, in a day. And I have a feed where every 5 seconds I get the current price of Apple. Market opens at 9:30 New York time, closes at 4 o'clock, right? I know how many data points are going to come, and I can add a little bit of margin. So I can calculate exactly how much memory I need. What I would do is I will pre-allocate that memory in the beginning, and then let that array just put the memory and have a variable size that tracks it. Because I don't want that every time a new data comes, I have a new array, because internally there's a malloc and whatever operations being conducted and all. I don't want to generate garbage. In fact, even in the code, and I'll show in the code, I actually don't use language defaults like options, which I showed. So that I mentioned that in the previous slide, that option thing that I showed here is a little bit misleading. because I actually don't use options. What I use is I don't use heap collected objects. I actually define my own structs which are based on stack. Here is my F# code, okay, and this is my base library, and I think it's going to be, oh, I don't really know why. Maybe I have to get out of, yeah, this is, oh, now I can, okay, good. Maybe I'll just not do a full screen mode because I'm interchanging the slides and code a lot. I actually want to show the code. See this? This is basically my implementation of options in F# with one line of code, and I've eliminated the normal heap-based object. So now I say maybe, which is option, yes, I have of some type, I'm using generics, or no, I don't have the data. The same thing is here for pair, right? Rather than using a tuple, by default in F#, I have my own pair, and I just say left or right, or first or second, you can call it anything you want. And then I have, I think I have the, is it vault? Yeah, okay. I think I should have common, yeah. This is my circular array right here, okay? In this circular array, I predefine the size, okay? This is the size, so I want to allocate. Then I have a position and a counter, and I just filled with dummy data in the beginning. And this is my get, which actually will get this data, and see it calculates the modulo of position and size, so I get the number. I insert, every time I insert, I increase the counter, so I know exactly how many data points I've got. I also increase the position, but then I take a modulo of it. So every time the position gets to size, it gets reset. So basically the data is moving in a circular way, and this is my circular array, and actually this is, was it? Yeah. This actually is encapsulated. It's a private data structure which is not visible to you. It actually gets incorporated into something called, I call it vault. I have my own naming system, but whatever. And in simple terms, what this is a thread safe store. So you see an object, and every time I ingest, what I basically do is I lock that object. So either you can read or you can write. And the way I've written this code is I don't actually use anything language default. I have my own implementation which is highly performant. So when I read, I basically lock the object and read all in one go. And this L is basically an array, and I don't even use the standard Facebook. I have my own, I call it vector. So you see these vectors. This is a read-only, because we are functional. I love immutability. This is a read-only interface. And vector buffer is another type that I have, which is basically write. So I take the vector buffer where I'm writing and then expose the read-only interface to it. So once the data has been written, you can't modify the data. Data is immutable. Data has to be immutable. Right? You can't change the price of Apple stock. I wish I could, but I can't. And so that's the code. So I'm basically, and I have this interface for store. So basically, I separate the interface for read and write, because when you look at this, this data store, the reader thread is exposed the interface for write, and the execution thread is exposed the interface for read. And data store is the main class. So I have exposed two views because I don't really have a reason. Reader should not be able to, it just has to write. And the execution only has to read, right? So that's the way I've structured the code. And you could go through the code. It's open source. I have the GitHub link at the end. But essentially, vector buffer because we are writing. So vector buffer, bool because if, let's say if my buffer is of the length 50 and I only have 50 data points, 30 data points, then I am not able to fill the buffer. So bool basically indicates that this buffer is full or not. Or if there is a bug, if there is a exchange has stopped transmitting data or something has gone wrong, this is basically an error indicator. So I just say get, I pass the array, and if the operation is successful, I get a true or true. If the operation has failed, I get a false, and the array itself will be filled with the data. There's a constant array. I don't allocate and deallocate because I don't want to call the malloc garbage collector, right? So basically I have this array predefined, the data just gets filled into it. And I know whether this is actual data or not. And then I have this source, basically, which is a dictionary of ticker. Ticker is basically the symbol, okay, ticker. and I can get what are the tickers, and I can get my buffer size. So this is the read-only aspect of it, data source, right? And it's a dictionary. And notice that I'm using dictionary and not a map, because this is actually C-sharp structure, not a F-sharp structure. F-sharp has map. I don't know why, but I find that C-sharp's libraries are usually much more performant than corresponding F-sharp library. God knows why. I think part of the reason is functional programmers, they love abstractions, so they create layers and layers of fancy looking abstractions that are really good to use, but the price you pay is performance, right? C# does not have that problem, plus .NET was written basically with C# in mind, so they really work very well. That is why the threading and the libraries that I actually use are going to be C# library, but what I tend to do is I have my own F# wrapper that I custom built on it, because I want functional properties like once I allocate this dictionary, I don't want you to modify it. So if you look through common, somewhere here I have, where is it? I think it's base maybe. Oh no, utils. This is it. C# has an immutable dictionary, so I create the objects. You can't modify these objects, and these are basically vector interfaces. So once you can't modify the dictionary once it's initialized. So usually it takes it's a generic code. You can take any list of whatever keys you have and a generator function that will generate the value. So that's how it works. Okay, where were we here? We were here, yeah. So what else should I show? I'll walk through the code, the entire code base, but let's actually move on and let's focus on reader's thread. So what does a reader thread do? You have an exchange. In US, we do New York Stock Exchange. You could do London Stock Exchange if you're in Europe, NASDAQ, etc. So there are a lot of stock exchanges, right? You can subscribe. Then you have a broker that you have to subscribe to. TD Ameritrade, which has actually now been acquired by Charles Schwab. I haven't updated the slide, but this actually should be Charles Schwab now. Tradier, Alpaca, Interactive Brokers. A lot of people use it. I hate it for God knows why. And for crypto, you have Coinbase, Gemini. I'm actually using Gemini as a data source, so I'll show the Gemini code, right? And this is what your bot would do. It will source data, okay? So like I said, there's a push model and there's a pull model. Pull model, I make a REST API, get me the last 15 minutes of Apple data or whatever data I want. WebSocket, I establish a WebSocket. I need data, and automatically the data gets pushed back to my feed, okay? And then what I do is I do pre-processing. Now, why do I pre-processing? What I often find is that when you subscribe to the data, it claims that it's going to give you every 5 seconds, but the timestamps can be a little bit off. Sometimes the data you will get is for 2 seconds, sometimes you'll get it for 6 seconds, sometimes you will not have data for connectivity issue, and often what data could be different. For example, what Gemini is basically giving you is trade data. What are the people trading right now? Like, how's the trade settled? It's basically ask and bid data. For those who don't know what ask and bid is, a stock exchange is an instrument where a buyer and seller, they kind of interact. So somebody would say, I am willing to sell this security for $200. So that's the ask price. The bidder says that I'm willing to buy for $150. The trade would not happen. A trade happens when the ask price is equal to or less than bid. And there is a small difference between ask and bid. It's called as a spread. And spread is what the exchange would make, because exchange also has to make money. So if you go through, basically, let's actually look at quotes data. So you look at quotes for Apple. Okay, stock usually don't have a high spreads. You will see B and A. B is what the bidder, A is what the asker, and there's a 2-cent difference. This is the spread between the two. So basically, if I am going to sell you Apple stock, I am going to sell you at this price, 181.95 right now. But you will buy from 181.97, and the 2 cents in difference is what the exchange would make as their profit, because exchange has to make profit. Okay? So anyway, so a trade would happen when the ask and bid kind of matches with each other, and then it goes to a thread safe data store. Now let's look at how the code is done here. So now we'll go back to code. So here I have a general socket class. So WebSocket.NET socket. This is a general socket class, right? All it does is it handles the connection, ignores, and basically takes some parameters. You have to specify data source, where do I put my data, etc. And there's an adapter. Adapter means sometimes, for example, Gemini has different WebSockets for different securities. So there's a WebSocket connection for Bitcoin, there's a WebSocket for Ethereum. Schwab would basically only have one WebSocket and you can trade anything. So what I have done is I've created different abstractions depending on broker, those who basically do single or those who multi, if you need one connection or multiple connections. And then it's all encapsulated in an interface. Remember, we talked about source. So basically, if you want to extend support for, let's say, a new broker that comes tomorrow, what you're going to do is you're going to create a class which basically calls this class and basically extends these classes, have the interface, and all the basic operations would be done by these class, and you will have to basically provide the specific functionalities. We'll look at Gemini, okay? So Gemini is an exchange that provides multiple WebSocket. This is the WebSocket feed for Gemini, okay? So it says that if I want to have a, let's say, BTC, you would basically have api.gemini.com, we want something, whatever, BTC USD or ETH USD. And if you look at it, this basically is encapsulated by my socket class, which actually parser. So parser will check the ask and bid price. It keeps track of what is minimum and best ask and best bid. When they match or they come very close to each other, and that's a configurable property, the difference. In this case, I think in my example, I have shown that my source is Gemini. I'm doing Bitcoin and Ethereum. My buffer size is about 100. Buffer is what I have specified. Ask bid difference is 0.05%. Timeout is 15. So if I don't get any data, so what my, I'll show you what timeout and linearization is. This is my pre-processing. So there's a buffer class. So remember I talked about if the data is missing or you need to adjust the data based on these timestamps. This is what the buffer class does. It basically creates a buffers of interval that you specify. In this code, I have specified 5 seconds interval. So say we want to do like a 5 second, I need a data every 5 seconds. So it creates a bucket of 5 seconds. All the trades that happened within the 5 seconds, it matches these ask and bid price, and then kind of averages out and gives me the price. And the bucket size, so I have 5 buckets, which means if I don't have data for the next 5 things, then for the next 5 ones, if I don't have a data for whatever reason, it actually will extrapolate. It actually does a linear projection of this data. And if I don't have data for 5 consecutive intervals, which is like 25 seconds, then assume that the connection is broken, in which case what it would do is it will reset the connection, because I can project the prices, but if the market is gone for 1 hour, my projection is not going to work because I'm only extrapolating the existing data, right? I just did 5 because I don't want to show too much of data, but usually I use 1 and bucket size 5. So I can project the data up to 5 seconds. And if the data does not have 5 seconds, what I would basically do is I will call the reset function. So this takes a reset parameter, and what reset would do is it will flag a warning, I'm resetting. It will clear out my buffers and start from the beginning. Okay, let's run this code. I think we have enough. There's a make, the code is there, you can, code is on GitHub, you can see the make file. So I have like debug mode, release mode, etc., etc. I use the standard .NET publish. So I'm going to do make debug. Okay, .NET publish, I generate code. In this particular case, what I'm actually using is I'm using a double moving average strategy. Let's talk about what a double moving average strategy is in a short while, but I got this sample bot.bin, which will start. This is a Nampo. It will connect to this one. It initializes the strategy. It creates some pre-processing and should start feeding. So this is now your Ethereum price that is happening. As you can see, that's the epoch. I think epoch is the number of seconds that passed since 1970, 1st of January, some standard Unix mechanism. You're getting Ethereum and Bitcoin prices right now that we are talking about live from the Gemini exchange. And if you observe, these timestamps are very evenly spaced. That's because I'm pre-processing. In fact, if I remove the pre-processor and show you the raw data, you will get whole bunch of raw data with irregular time intervals. But I kind of bucketize and linearize, and that's why you're seeing it neatly arranged. And this is being filled in the data buffer. So 15 minutes or whatever your data size is, 100 data points, right? So 100 into 5 seconds, which is 500, approximately, 8-9 minutes. So 8-9 minutes of data. Based on that 8-9 minutes, you will apply your strategy and make a decision that you want to trade or not, okay? So this is your live feed. Now let's actually go, and this is obviously WebSocket pull connection, we talked about it, okay? So when you get the data, you actually get a data in what is called as candles or Japanese candles. And candles means for an interval of 5 seconds, you have an opening price, at what price did that open, a closing price, and within that interval, 5 seconds, 1 hour, it's configurable. What was the highest and the lowest, right? That's what this symbolizes. And these candles come in 2 colors, green and red. So if it's green, it means this is a positive, so it's a bullish. Red means it's bearish. So green, opening price is going to be the bottom one and closing price is the top because it increased during that trade, right? This is the bullish one, which means it opens and it went lower. So basically color, so the edge of this bar will tell you the opening and closing price. The color will tell you whether open is in the bottom, close is on top, or vice versa. And then you have these edges, and that basically tells you the minimum, maximum during this interval, okay? Crypto, you don't get these candles, but stocks, you do kind of get the candle, but a stock will not vary that much in 5 seconds, so mostly your open and close price is almost the same. But options, you will, if you do options and futures, you actually will see a huge variation, sometimes like 5-6% during a single 5 seconds interval. This is a tool called Active Trader Pro, connects to Fidelity. So this is an NVIDIA candle that you are seeing. The market has closed, that's why you don't actually see any updates, but if we were doing this talk in the morning, you would see the live data. This doesn't use candle, but uses something similar. You still see the green and red here, right? And you see these notches here. So these are your opening and close price. So it opened at this price, which is going to be whatever, this is 9:30, 8:30 something. That's where it opened during this, this interval is, what is it? 1 minute interval. So these candles are 1 minute interval, okay? Within that 1 minute, it opened at this price, it closed here. That's the minimum and maximum. And here you actually will see the volume, right? All brokers usually have some kind of code like that. So if you're using Charles Schwab, they have Thinkorswim, etc., whatever. And even if you're not based in US, you'll have your European or Asian counterparts that will show you all these graphs. That's the candles. You basically get candle data. And now, so this is an example. I showed you a live example of candle data, okay? And basically now we talked about execution thread. So we know what a reader thread do, WebSocket, we are getting the data. We have execution thread. I have still a lot to cover and I'm a little behind the time, unfortunately. So I'll skip through some of the stuff. Read data, you find an opportunity, place an order, no, go back and read the data, monitor the trade, stopping conditions, if no, read data, if the exit, standard. Typically in this code, what I have done is I have different kind of sources. It's not complete yet, it's an ongoing project and I love contributions if anybody wants to contribute. So I have different classes for sources, different kind of buffering scheme, different kind of broker. So if you want to build a bot using this code, what you do is you basically build your own strategy. So this is a strategy class. All you have to do is basically, this is a F# interface. Basically for Java people, this is basically an interface, F# interface or C# interface, whatever. Takes a ticker and a vector of data and it generates a maybe. Maybe is an option of order. Do you want an order or not? This is an order entry. Order entry is basically nothing but this is the price I want to enter. This is the price I want to, this is, where is order entry? Yeah, profit price, loss price, what is my profit percent? This is an entry, right? This is a Japanese candle structure, buffer, okay? And all you have to do is, let's actually look at this program. What have I done? I have a double moving average strategy. Takes a strategy, takes 2 averages, short and long. If short crosses long, it means I have a buy signal. So this is my strategy. All I have to do is implement this execute function, override this execute function. I take this execution engine, I I put all my parameters. Alpaca is the broker that I have. Usually you'll have some secrets like login password credentials. You obviously will not put it in the code, put it in environment variable that you read it. These are my tickers. I'm using Gemini as source. I configure my parameters. All I'm doing is configuring my parameter, putting the strategy, plug it in the framework. So let's say if you want to build your own bot, you will have something similar, create your strategy, put the parameters of what you want, plug it, and the execution would work. And this is your execution thread right here. Okay, so that is happening. Yeah. So this is double moving average, I actually explained. This is the GitHub code for all the code that I'm showing, right? Like I said, it's open source. This is it. The slides also, I have linked it here. These slides might be slightly different from the ones I'm showing, but I'll update them. And if you want to, so this is the sample, and these are all the adapters. Right now I only have Alpaca and Gemini, but I'm planning to add TD, Ameritrade, Schwab, everything. So over the period of time, you will probably see a lot of adapters, depending on the brokers. How am I doing on time? The data feed is still happening. That's wonderful, 342. I think I'm in good shape. Okay, so the main part of what I wanted to show. Now, let's actually go into, so far we have talked about the base, right? We have talked about data, we have talked about execution, but I haven't really talked about, okay, how do I make a decision? Okay, but before that, I actually want to cover back testing. So we know what a back testing is. We have a historical data, so most of the brokers would give you historic data. It's a good indicator for future, and this is where functional programming is fantastic because it lets you write correct code in a very short few lines of code, so you trust more code. And when you're doing back testing, you actually can use all the language defaults because at that point you're not concerned about garbage collection and all those things, so you're not bothered with that, right? So you just use the standard language frameworks. You don't really have to care about efficiency also. So how do we make a decision, right? How do I know whether I want to enter a trade or not? Now, there are what we call as technical indicators. Technical indicators basically tell you whether you want to buy or sell or what you want to do. Now, people spend 2 years learning technical indicators. I'm trying to compress it for 10 minutes, so I'm not going to talk a lot about it. But what I have is, I have a list of some websites I can go to. I can give you a lot of technical indicators. A whole lot of technical indicators. You can go one by one. I think I'm using some moving average one. The example I have is about moving average. As I mentioned, you can spend 1 or 2 years learning all this. This is a list of technical indicators. Broadly speaking, we have 4 categories of technical indicators. So here what I have is, I'll just explain broadly what the categories of technical indicators is, and then I'll pick 1 or 2. And I'm actually going to show them again. Let me just do a quick, okay, I have time. I think I've covered quite a lot of information. Okay, the feed is still happening. Feed will just keep on going until I stop it. So you're still getting good feed here. Okay, wonderful. So you have basically what is called as trend indicators. What is a trend indicator? A trend indicator is a type of indicator that tells you what the current trend is. Is the underlying security, whether it's future option, whatever you want to do, is it increasing or decreasing? So what you want to do is you want to judge the trend. Okay, I think Apple is increasing, so maybe I'll enter the trade now and I'll exit after 5 minutes. Momentum is basically similar to trend. Momentum is the speed of increase, whereas trend just says the direction of increase. That's the difference. Volatility is what is the fluctuation, like how much is it volatile. And volume is what's the volume. Volume also talks a lot about, because volume also has a big role to play. For example, now this is more of a complicated topic, but when you actually look at price of a stock, what is a price? Price is basically somebody willing to sell you at a certain price. Now that's actually a little bit deceptive. For example, let's say I want to sell a house, okay? And I have these 10 houses for the price of 1 million. But I have to find buyers for those 10 houses if I want to sell all 10. For the first house, I can find a buyer. For the second one, I can find a buyer. The third one, I can't find a buyer who's willing to pay 1 million for that house. The buyer says, I'm going to pay only 800,000. So if you want to sell, otherwise get lost. In that case, I will have to lower the price. So volume basically and that's the volume of 1 million, right? So market works the same way. When you see an Apple price of $200, what it's only telling you is the highest person who's willing to sell is willing to sell for 200. That does not mean you can buy 1 billion shares of Apple for, you probably can't buy 1 billion anyway, but let's say you want to buy 1 million shares of Apple, that doesn't necessarily mean that you'll get it at 200, right? Certain people will sell it for 200. Only 10,000 people are willing to sell you for 200. The remaining 20,000 says, now I want 220. So if you buy 1 million, you will not get the 200 price. You're actually going to get a price which is slightly higher. So volume basically is an indicator of how much can you actually trade with that. And for retail people like us, we deal with numbers that are anywhere between 1,000 to 1 million. It's probably not going to be important if you are trading securities of common stocks. If you go into options, that's where things get a little bit complicated. Even then, I think retailers don't really have to worry about volume so much. But if you are a hedge fund, right, you're making trades that are billion. At that point, volume will start playing a role. I want to continuously do a time check. Okay. Most of the time, there are two things that I want to mention here. Most of the time, people will use combination of technical indicators. So just because the trend indicator says positive, buy me, does not actually mean you should buy. Think of indicators as an opinion, somebody's opinion, but you don't really make a big decision in your life by just listening to one person. You listen to 10, 15 people, you think on your own, and then you make a decision. So basically in real life, you have a whole bunch of these indicators that you will use together. You will use some trend, you will use some momentum. Okay, I know it's going, but I also don't know how far it will go. So you'll use some momentum. You also want to know how much volatility. What if it flickers too much and I put my bracket order and before it hits the positive, it hits the negative because the volatility was too high, right? So I want to know something about volatility. I want to know what should my trade volume. So in real life, you will use a combination of indicators. Most of the proprietary hedge funds actually have their own proprietary indicators that you will not find in website. In fact, if you use any one of those web indicators that I'm telling you, almost surely you will lose money. And the reason is that those indicators, once everybody knows about it, everybody uses them, they've lost their value, right? So it's more there to teach you, but in real life, you will come up with your own indicator. Now, this is where I want to clarify something. Market is a spring. When you're doing automated trading, what you are essentially doing is you discover a systematic inefficiency in the market, right? And you exploit it to make money. But as you exploit it, what happens is that market will start adjusting. So your strategy will work brilliantly in the beginning, but slowly it starts getting ineffective. And at some point of time, the same strategy that was making profit for you a month ago will now start making loss for you. And at that point, you have to stop and try a new strategy. If you ever wonder, why do hedge funds employ quants? Because, hey, let's say I am a quant, I give you a great indicator and I make a great way of how you can make money. You apply in the market, you make a lot of money. You could just fire me because you already know you can make money. In reality, it's not going to happen. You can make money only to a point before the strategy fails. I've been shown 5 minutes, so I'll have to hurry up. Okay. So here is a momentum. You can read about RSI, Relative Strength Index momentum, right? Okay. This is my F# code, 5 or 6 lines of code, something like that for RSI. Okay. I'm just going to compare it to some random dude who implemented in Java. And okay, yeah, there you go, 60 lines of code that I didn't even bother to read. But this is how awesome F# and functional programming is to do this kind of stuff. Another one, 4 lines of code, you can read about it. Due to lack of time, I can't go into details. Something we call as support and resistance. You see these graphs. Resistance is the top edge of the curve. Support is bottom edge of the curve. Here is the code for it. Right? Support and resistance calculation. Then you have various candlestick patterns. Top 16 patterns indicates what you can and do. Candlestick patterns. Where is candlestick? Bollinger bands relative. Yeah, candlestick patterns. read about all these candlestick patterns, I can share the links. Links are already there on the PPT. Here is my 5 lines of F# code, right? This is what makes F# really good. Bollinger bands in which you can fluctuate. Strategy where it touches the upper band means buy, where it touches the lower band. Here is an implementation, 6, 7, 8 lines of code. And this is what I mentioned. In real life, you will use various technical indicators in various type of strategies, because one strategy may not work, right? So you'll have a bunch of strategy, you do all analysis and you generate an order. Wrapping up, consider putting stop losses on trade, include terminating conditions, monitor trade actively, always have a quill switch. I trade when I have a mobile phone, I can with one press of a button shut down the machine on Google Cloud that is doing trading. So I have a kill switch. If something goes out of control, I know how to stop it right away. Through my phone, I can monitor everything. Because my bot is running on Google Cloud, it's sending logs to Stack Driver, I read those logs on my phone. Evolve strategy continuously, you have to adapt to the market. We'll skip the summary, bots can be used for trading, functional programming is great, backtest your strategy, we already talked about controlling risk. The code is here. If you want to contribute, you're welcome to. I wish I could walk through the code, but you can do it yourself, or you can meet me in the corridor and I'm happy to walk you through. I don't have that much time, I think. So, questions, please. Yes, sir.
Well, I saw that you're using observables, so I wonder from functional reactive programming perspective, it seems like a model that can fit to reactive. How much iObservables and reactive extension did you go to use it?
I use it because when I'm getting a feed, I need an automatic way of ingesting the data. So I think I only have iObservable once or twice in the code. It's not too much from the WebSocket.
Did you consider to use them?
Yeah, that's how the standard implementation for WebSocket is, because WebSocket is a push model, right? It's not a pull model. If you're doing a pull model, you don't need any iObserver. But if you're doing a push model, then you don't know when the data is going to come. It will come sometime. So you want a callback function that whenever the data comes, callback function will get activated with this data. Yes, sir.
Would there, 2 questions. Would there be any utility, you think, in terms of an open source contribution to, I believe it's XGraph. It's one of the F# libraries. It's just it's kind of like, it's like Python's like graph library, but it's for F# and the data scientists use a bunch. Do you think there'd be any utility for instead of having the terminal, like the output of the terminal, just being able to?
You could create your own. I mean, I haven't.
Handy for other people if I contribute that.
I would love if you contribute.
Okay.
The reason why I don't want interactive is because I can't have interactive. See, my stuff runs on the cloud. So if I'm doing backtesting and all those, I can use all that. But if it's actively running, I can't have a UI.
Yeah. Okay.
Right? So that's why it doesn't work. But if you're doing an ad hoc manual testing, like kind of semi-automatic, sit in a computer all day long, yeah, that works. But then you already have that. You already have Active Trader Pro, and it has all the indicators. So the RSI code that I actually showed you, you can actually, here is an RSI, relative strength index, and you can actually plot. So the thing is, you can do all that stuff, but I think it's already done. So I'm not sure how beneficial would it be. You want to automate it, right? The thing is, you go on a vacation and your money works bad. That's the goal. If you want to do it actively, you already have the stuff.
Cool. Second question. Do you think another one of the big reasons why you chose functional programming for this, it sounded like that idea that as the market goes on, whatever your strategy is now isn't going to remain the same because it's functional. You can just like easily switch stuff out and compose stuff.
Yes. So that's one of the things. I just think that functional programming as a paradigm is beautiful paradigm for doing that stuff. Most of the people use Python, which I find is horrible, but I don't think the reasons are technical. The reasons is that it's very hard to find a person who's a good programmer and a good trader, right? And usually you'll find people to be good trader but not good programmer, right? And then if you're not a good programmer, Python tends to be the most easiest, so that's why they use it. But I think for a good programmer, it doesn't matter. Hedge funds would use C++ for latency reasons. But as a retailer, I don't have to be concerned about hedge trader. They are not my competition. My competition is going to be other retail traders. Because what happens, and I don't know how the time slot is going for QA. Okay, 1 minute, yeah. The thing is that there's a lot of advantage between hedge funds, how they operate, and how retailers with these bots. Hedge funds, when you invest somebody else's money, there are a lot of legalities. For example, in US, you have an organization called FINRA that actually regulates what you can and cannot do, and hedge funds have to operate within that legal framework. As a retailer, I'm putting my own money. You could lose it or gain whatever. There's no law as long as you don't do something illegal, right? So hedge funds is not something that I usually compete with. Plus, hedge funds, they don't make millions of dollars in profit. It's too little for them. For me, that's too much. So we operate in a different space. I do what I call as a medium frequency trading, where my trading decisions are seconds, whereas hedge funds operate in milliseconds, right? F-sharp works great for me for that purpose. I think you had a question.
Can you show one second how a buy via the API would be done?
I think I'm out of time, so we can meet in the corridor and I'll show you there.